Okay, guys, welcome. Today we're going to talk about rectangular coordinate systems. Okay, so all that we really mean by a rectangular coordinate system is we're really just talking about what you think of when you think of a graph. Okay, so just to sort of talk about some of the basics of graphing, to draw a graph, of course, the first thing you do is you draw a pair of perpendicular lines, right? So I'll sort of do this off to the side, even though we have a diagram already here. So your perpendicular lines would, of course, look something like this. And where they intersect, we refer to that as the origin. Okay, and of course, usually the horizontal axis we refer to as the x-axis, and the vertical one we refer to as the y-axis. Okay. Now, of course, together, we refer to them as coordinate axes, and together they constitute what's called a rectangular coordinate system, or we could also call it a Cartesian coordinate system. And all we really mean by a rectangular coordinate system is that when we plot points, we specify their position as it appears to the left and the right and up and down, right? So sort of like moving like a rectangle. Another thing that you may see occasionally is that we usually number the quadrants. And of course, we usually refer to this quadrant as the first quadrant because in this quadrant, both coordinates are positive, and that's usually where most things in our world happen, right? We usually consider both coordinates being positive. And then we move in a counterclockwise fashion to label the rest of them. So this would be quadrant 2, this would be quadrant 3, and this would be quadrant 4. All right, so that's one thing that you also may see in regards to a graph. Okay, so let's first look at how we would plot a point. So let me draw my coordinate plane here, and I'll put some hatch marks on here. Okay, and we want to plot the point 3, 2. Okay, now while we're here, we'll talk about just how to plot in general. Okay, so your points are always going to be given in the form x comma y, right? So the first coordinate is telling you the x position, and the second coordinate, of course, is telling you the y position. So the x coordinate is telling you to move left or right. You're going to move left if the number is negative, and you're going to move right if the number is positive, right? And then the y coordinate is telling you to move up or down, depending on, again, if it's positive or negative, right? And when we say move left, right, move up and down, we mean starting at the origin, okay? So in this case, I have the point 3, 2. So the 3 tells me I need to move to the right since it's positive by 3 spots. And the 2 tells me I need to move up by 2 spots. Okay, so of course, to plot this point, if I start at the origin and I move 3 points to the right, that would, of course, put me here. But then I need to go up by 2, and that would put me here. So this point right here is the coordinate 3/2. Okay, so that's plotting the point 3/2, or sorry, 3, 2. Okay, now in this example, we want to find the coordinates that are given to us. So let's just go ahead and we'll do it. So for example, this point right here, we see that we had to move 3 points to the right and 1 unit up. So that's, of course, 3, 1. This point up here, we had to move to the right by 5 and up by 3. So that's a 5, 3. Now this point over here, we had to move to the left this time. So that's a -2, but still moving up. So that's a +5. Now this -7 right here is not off the x-axis, right? So we didn't move up or down. We still moved to the left by 7, So we have a -7 there, but we didn't move up or down, so we're going to put a 0 there. All right, and then similarly, we could say at this point is -5, -1. This one will be a -2, -3, and this one will be a 2, -3. All right, so hopefully that's something that is pretty easy to get the hang of. Okay, so let's go ahead and we'll plot a couple more points. And then we'll also, of course, talk about what quadrant that they're in. Okay. Now, of course, you don't even need to plot them to state what quadrant they're in because, of course, you know that in this quadrant, both are positive. In this one, the x coordinate is negative while the y is positive. Here, they're both negative. And here you have a positive x but a negative y. So as soon as you see that in your point, you can automatically say what quadrant they're in. For example, A is 1, 6. So I didn't put 6 here, but A is right here. And of course, this is quadrant 1 because they're both positive coordinates. All right, and then we have point B, which is -3, -3. So that's going to put us here. And of course, this is quadrant 3. Okay, and then we have point C, which is -3, +2. So that's going to put us here. And of course, this is quadrant 2. Now point D is 2, -5. So that's going to put us here. And of course, this is quadrant 4. All right, and then we have 4, 0, which is just going to be right here. And that's not really in any quadrant, right? We're sort of on the boundary, right? And then 0, -1 is similar, not really in any quadrant because it's right on the axis. All right, so that's a couple more examples of plotting some points. Okay, now we're going to talk about how we can use the coordinate system to provide graphs of equations, right? So if you have a two variable equation, the coordinate system gives you a way of sort of visualizing your relationship between your two variables, right? Now, for now, we're going to talk about just using a table of values to graph an equation, right? Now, we'll talk about later on some shortcuts that you can use for particular types of equations, but for now, we're just going to talk about graphing using a table of values. Okay, so in part A, we want to graph y equals x plus 1 absolute value. Okay, so some common choices. And again, if you have y by itself, I shouldn't say again because I haven't mentioned this yet, but if you have y by itself, you're going to test easy values of x. So some common choices are like -2, -1, 0, 1, and 2. Okay. Now to get the y values, we just plug each of our x values into our equation and see what we get, right? So your y value for -2 is going to be absolute value of -2 plus 1, which is absolute value of -1, which is just 1. Okay. When we do this for -1, we get absolute value of 0, which is just 0. And then you can show that when you plug in 0, you get 1. You plug in 1, you get 2. And when you plug in 2, you get 3. All right. Now, what do all these things tell us here? For example, this tells us that -2, 1 is a point on the graph. Right? This tells you at -1, 0 is a point, 0, 1, 1, 2, and 2, 3. So now we can plot this. So if we plot each of these points, we'll have a good idea of what this looks like. So negative 2 comma 1 is going to be here. Negative 1, 0 will put us here. 0, 1 is here. And 1, 2 is here. And 2 comma 3 is here. Okay, so it looks like we're going to get something like this. All right, and if you're ever unsure based on how many points that you have, you can always plot some more until you're confident that you have an accurate depiction of what your graph will look like. Okay, so that's absolute value of x plus 1. Let's take a look at 4 minus x squared. Okay, so we'll make a table of values again. Okay, and we'll just go through this a little bit quicker now. When you plug in a negative 2 in here, you're going to get 4 minus negative 2 squared. I want to show out this example just so that you're careful about plugging in that negative 2. All right, so if you plug in a negative 2, you want to make sure it's in parentheses. So this becomes 4 minus 4, so you get 0. Right, when you plug in negative 1, you're going to get 4 minus 1, so you're going to get 3. And then 4 minus 0 is 4. 4 minus 1 squared is 3 again. And 4 minus 2 squared is 0. 0 again. This should be 4. I'm going to mess something up. Okay, so let's go ahead and we'll graph it. Okay, so if we plot these points, we have a negative 2, 0. We have a negative 1, 3. We have a 0, 4, a 1, 3, and a 2, 0. So of course, looks like we have something like this. And of course, we're using the arrows to indicate that this is just sort of going to go on forever, right? Because it's not just these 5 points that are on this equation, it's an infinite number of points. You can plug in any x value and you should get something out. Okay, so then the last one is y equals absolute value of x minus 2. Okay, so we'll do another table of values. Okay, so now when we plug in negative 2, we're going to get absolute value negative 2 minus 2. So we're going to get absolute value negative 4. So we get a 0. Okay, negative 1. I keep doing that. This should be a 4. Negative 1 minus 2, we'll get a absolute value negative 3. So we get positive 3. And then you can show that when you plug in 0, you get 2. When you plug in 1, you get 1. When you plug in 2, you get 0. Okay, now if you plot these points, here's what we're going to get. So we have negative 2, 4, negative 1, 3, 0, 2, 1, 1, and 2, 0. Now you might notice that this doesn't really look the same as our absolute value equation that we had before, right? If you look at our absolute value equation, we sort of have that V shape happening, right? But here, if we connect them, it looks like we only have a line, right? So if this ever happens and something doesn't look right, let's just plot, say, 2 more points. All right, let's test x equals 3 and x equals 4. And of course, this is where the problem goes away, because if you plug in 3, you get absolute value of 3 minus 2, which is 1. And if you plug in 4, you get 4 minus 2, which is 2. So this will indeed come back up, and we'll get something like this. All right, and this is, of course, the typical shape for an absolute value graph. You sort of get that V shape. Okay, so those are a couple examples of graphing. Now, if you have an equation that has x by itself, instead of y by itself, like we did before, now here we have x by itself, you actually want to make your table of values slightly different. Right? So instead of testing easy values for x, we're going to test easy values for y. That's going to make obtaining these points a lot easier. Okay, so now if we find our points here, now x is going to be -2 squared plus 1. And that will give me a 4 plus 1, so we'll get a 5. Right? And of course, similarly, if you plug in -1, you get a -1 squared, which is 1 plus 1, so 2. This will give me a 1. This will again give me 2, and this will give me a 5 again. So now when we graph this, here's what we'll get. So it looks like my first point is 5, -2. And then we get a 2, -1. And then we get a 1, 0. And then a 2, 1 again. Well, 2, +1 this time. And then a 5, 2. So for this one, we actually get something like this. Okay, so that's part A. Now part B, again, we have x by itself this time, so we want to test values of y, just like we did in part A. So again, we'll test -2, -1, 0, 1, and 2. Now, if you plug it in -2, again, this is where you get sort of the 4 minus -2 squared. So you get 4 minus 4. So this is 0. All right. So then, of course, similarly, if you plug in a -1, you're going to get 4 minus -1 squared. So you're going to get 4 minus 1, so 3. And then similarly 0, and then 3, and then there should also be a 0, right? Yes. Okay, so then we have, let's see, so I need to go, this is 4 again, I keep doing that. Okay, so we need to go 1, 2, 3, 4. And let's go ahead and plot our points. So it looks like I have a point at 0, -2. I have a point at 3, -1. I have a point at 4, 0. I have a point at 3, 1, and at 0, 2. So it looks like we have something like this. All right, so these graphs look a little bit different if you have x by itself instead. Okay, that concludes this video on the rectangular coordinate systems. Hope you enjoyed, and I will see you next time.